Hey guys, it's Magda here, and today we are doing a full Algebra 1 and 2 revision. Great practice for any Living Cert students or fifth year higher level 1 getting ready for their Christmas exam. So let's get started. The first thing that you need to know is how to factorize the algebraic expression. And there are two new formulas that you met in fifth year, and that is the difference of two cubes and the sum of the two cubes. They almost the same, but you can see that the sign is different. So the then it's minus two pluses or plus minus and a plus. And the last formula is called the difference of two squares. And this is something that you probably know from the junior cert. So if your question is simplify something like that, what they basically want from you is to try to factorize and then cancel as much as you can. So you can see that the top of this fraction is the difference of two cubes. So I open up the two brackets, one small, one big. Then I have minus because it's the same, and then opposite always positive, and we get x minus 3, and then x squared plus 3x plus 9, and then the bottom stays the same. I can't really factorize that, so I keep it this way. And now division of two fractions means that I actually multiply by the other fraction to be flipped. So I'm going to change this, and I will get x plus 3 on the top. And with this one here, I could definitely factorize the x squared. So when I do that, I get x squared and then x squared minus 9. And this thing over here also could be factorized using the difference of two squares. So that will be x plus 3 and then x minus 3. Now let's cancel what is the same. So that x plus 1 can be cancelled with this one. X minus 1 with this x minus 1, and okay, over here again, can't. How do we multiply the two fractions? Is top by the top, bottom by the bottom. So at the end, I will get 1 over x squared, and that's your final answer. Okay, so let's have a look over here. Another thing that you need to know is how to rearrange the formula, how to change the subject of the formula. And that means basically that you want to get the formula for the letter that is in your square brackets. So what do I need to do if I have a fraction on both sides? Remember, guys, that if I have fraction like this, to get rid of the fraction, I can do cross multiplication, and one multiplication will be a left side, and my other multiplication will be the right side. So B by C, and that's what I do over here. So if you look at the first one, I get J plus K is the same as KH. I move now my K's to one side, so I will get K minus KH is equal to minus J, okay? And now I want to factorize the K. So then I get 1 minus h is equal to minus j. Divide both sides by 1 minus h, so it will be minus j over 1 minus h. And that's my final answer. So let's do the same over here. Again, I do the cross multiplication. So it's 2pq minus 2px, and that is equal to QP, which is the same as PQ plus QX. Okay, again, X is on one side, numbers on the other side. This time I picked the right side for my X to avoid the minus, so I will get here 2PQ minus PQ. And then on the other side, I will have 2px plus qx. Let's factorize the x as a highest common factor. So then in the bracket, I will have p, 2p plus q equals to just pq. And now again, I'm dividing both sides by that. So I get pq over 2p plus q equals to my x. Okay, so thank you. And now let's move on to simplifying algebraic fraction. So anytime when you have something like this, the best thing is to use the method 1, 2, 3, 4. Okay, I explain you what that means. So if I have to add or subtract two algebraic fractions, I can use the rule. So the bottom is always 2 by 4, and then the top is cross multiplication. So 1 by 4, and then plus or minus 3 by 2. Okay, so to subtract these two, I number them as 1, 2, 3, 4, and then I follow the rule. So my bottom will be x plus 2, as this is my 2, and then x minus 1, and then the top will be 5 by x minus 1 minus 3x by x plus 2. Okay, now what do we have to do with this? Let's simplify and remove the brackets to get the simplest form, and that will be 5x minus 5 minus 3x squared minus 6x all over x squared plus just x, and then minus 2. The first part, the top part, will be minus 3x squared minus x, and then minus 5x squared plus x minus 2. And that's your answer. So for this one, you can see that this one is slightly different. If I would cover this, then you could use probably the same rule 1, 2, 3, 4. But because I have that third fraction, I need to see what is here. Okay, so I factorize that bottom and I get two brackets, x minus 1, x plus 1. So that is exactly my common denominator that I would get from using the rule 1, 2, 3, 4. So yes, again, I do what? I put the common denominator as x minus 1, x plus 1, and then I do what here? So whatever I do to the top, okay, or to the bottom, I need to do the same to the top. So over here, to get my new denominator, I need to multiply x minus 1 by x plus 1. So I do the same to the top, x plus 1, and that gives me x plus 1 to be squared. Then minus, for this one, I multiply it by x minus 1. So I do the same to my top, and that will give me x minus 1 to be squared. And then this is something that I already want. This is my common denominator, so I just keep my minus 4. So now what do? We expand the brackets on the top, so that will be x squared plus 2x plus 1. Be careful with the minus, so I'm going to put the brackets, expand this, x squared minus 2x plus 1, and then minus 4 all over x minus 1, and then x plus 1 over here. Let's simplify it. So that will give me minus x squared plus 2x minus 1, as I changing the sign of each term inside the brackets. And now you can see that the x squares will cancel. Then I left with 4x, and then 1 minus 1 is done, and then 4x minus 4 all over. I do not remove that brackets because I want, maybe I could simplify even more at the end. So x plus 1, and of course I can see that the top has a common factor, so I can factorize the 4, and then I get x minus 1 bracket x minus 1 x plus 1, and then again I have something that is the same, so I cancel this out, and the simplest form of this will be just 4 over x plus 1. Okay, now let's move what we have next, and that is definitely quadratic equation, one of the most important um, topics on your leaving cert. So first of all, what you need to know, okay, that the quadratic equation can be expressed in three different forms, okay? So I could have a standard form, which is, I'm going to write that as a function. So let's say 2x squared plus 3x plus 1, and then that form will give you some information about the graph. So first of all, that it's a U shape as the leading coefficient is positive. Oh, that should be a U, not n. And then it also gives you the y-intercept, which is just y equals to 1. If I turn it into vertex form, factor form, then what I get over here is definitely my roots. Okay, that's the places where the graph hits the x-axis. So it's -1 and then x equals to 2. And finally, the most important one is the one where you can write it in terms of this. It's called the vertex form. And that form gives you vertex, coordinates of your maximum or minimum turning point, and also the axis of symmetry. But how will I go from the standard to a vertex form? As you can see over here, first of all, what you need to do is definitely completing the square. So what does it mean? I take my x squared minus 10x plus 20, and you always half it and square it the middle term coefficient. So that will be minus 10, half it, that's -5, and then you square it, so that will be 25. Now I keep the first two terms, x squared minus 10x, and then I add 25, and then minus 25 and plus 20. That's what you always do, guys. So you're adding and subtracting the same number that you got. Here you factorize that, and when you open up the two bracket, it must be the same bracket. So factors of 25 that add up to 10, so that's 5 and 5. From this I get just -5. So my vertex form is x minus 5 to be squared minus 5. And then look what they ask next. Hence, identify the minimum point of your function. So the vertex form will give you the minimum point. Remember, it's the general formula x minus p to be squared plus q. So my minimum point is 5, as this is my p, and minus q for y coordinate. Now the next one is to find the roots of this quadratic equation. So I can factorize it, I can use the minus b formula, and now I'm going to show you one more way of finding the roots by using the vertex form. So I let my x minus 5 squared minus 5 equal to 0. Okay, now I want to keep the x on the left, and I move everything else to the right side. So look what we do over here. I keep x minus 5 squared, move minus 5, so that turns to a 5. The next thing that I would like to get rid of is the power. So the square root on both sides, as the square root undo the power, and then I get x minus 5. Remember to add plus or minus on the other side, as we should have two solutions, square root of 5, and finally we move minus 5. So my two roots in short form will be just 5 plus or minus root 5. And that's your final answer. And then for the next one, now we have the roots of the equation are -12 and 2. Find the values of a, b, and c. So I can use the two ways. I can solve it using two different techniques. So first of all, if I have x equals -12, x equals to 2. So first of all, if I have a roots, I have two factors, and that factors are x plus 12. So I just moving my roots back to the left side, and then x minus 2. And then I multiply out the two brackets, and I get x squared minus 2x plus 12x minus 24 equals 0. I add the like terms here, and I get x squared plus 10x, and then minus 24 equals to 0. So the a is equal to 1, b is equal to 10, and c is equal to minus 24. But if you have if you have a root and you want to form the quadratic equation, we could also use the lovely formula x squared minus sx plus p. So to find any quadratic equation with the given roots, we only have to find the sum and the product. So the sum of minus 12 plus 2 will be minus 10, and the product will be minus 24. I apply to my formula and I get x squared, then minus and minus 10 will turn to a 10x, and then minus 24. Okay, and make sure that you know this formula, and it helps a lot, especially on the leaving set. Okay, so now let's have a look over here, another leaving cert question. So as you can see over here, I have again quadratic function, and they want you to change it into a vertex form. So before I turn it into a vertex form, make sure that there is x squared on its own. So I first of all factorize the 2. And when I take out the 2, I get x squared minus 7 over 2x minus 5. So now if I have 1, I can take the middle coefficient and I half it, and then I square it. So you can put that like this into the calculator if you don't know what that is, and that will give you just 49 over 16. So then again, I write everything, x squared minus 7 over 2x, and then I add 49 over 16, close the brackets, take away 49 over 16, and then minus 5. We factorize this. I know, guys, that factorizing, especially with the fraction, could be challenging, but remember, there will be always one bracket to be squared. So what you basically do each time, you square root the first term and then square root the last term. So that will be x minus 7 over 4. From this, you get minus 129 over 16. Remember that we have another bracket 2 with the 2. So now we need to go back and remove that by multiplying everything by 2. So that leaves me with 2 bracket x minus 7 over 4 squared minus 129 over 8, because the 16 and 2 will cancel. Okay, and this is my vertex form, a x minus p squared plus q. And then the next question, again, you can see that you have to write the minimum point of f. So they're looking for your p and q, and that will be 7 over 4, as this is my p, and minus 129 over 8. Okay, the next one is to explain why f must have two real roots. So what we have to do over here, I need to show that if they mention something about the nature of the roots, then I have to show that my discriminant is greater than 0. Okay, so my equation was 2x squared minus 7x minus 5. Okay, so that's my A, that's my B, that's my C. I sub it into the formula, so it will be minus 7 squared minus 4 by 2 by minus 5, and my discriminant will be 49 plus 80, so it's 129. It's greater than 0, so that means that my function f must have two real roots. And then finally, the last one, they want you to find the roots of that quadratic equation. So if they are in that form, okay, the best thing in this case will be use the minus b formula, as I think that the vertex form would be too challenging. So easy, just filling into minus b formula your A, B, and C, and use the calculator to find your two roots. I'm not going to do it this here. Okay, and then the next one, okay, we have another two functions. One is linear, the other is quadratic. And what they want me to do over here is to find the h of x. And h of x is g after f of x. So anytime when you have something like this, you change that dots into brackets with another function in it. So that means that I need to find g of f of x. So I take my g and replace it with the function 2 minus x. So I sub that in for the x into my function g. So that will give me 2 bracket, and then I have 2 minus x to be squared minus 9. They want you to show that this can be expanded to something like this. So let's expand the brackets, and then I get 4 minus 4x plus x squared minus 9. Remove the brackets, so that will be 2x squared minus 8x, and then 2 by 4 is 8, minus 9 will give me minus 1, and that's my final answer for this one. And then the next one, they want me again to express it in vertex form. So to get the vertex form, I need to completing the square, but first of all, I need to factorize the 2 to get x squared minus 4x minus a half, and then we half it and square it. So that will give me 4. Okay, so now I get 2 bracket x squared minus 4x, again add 4 minus 4 and minus a half. So this is the same bracket. Do you remember when I said square the first, square root the last, and that will be x minus 2 to be squared minus 9 halves with the 2. Remove the big brackets, guys, and then I get 2x minus 2 to be squared minus 9. Okay, remember that form will give you the vertex. Okay, so now hence or otherwise find the coordinates of your turning point. So they ask again for the P and Q, and that will be 2 and minus 9. And then for the next part, C, the function k of x is the image of h of x under the translation. The coordinates of the turning point of k of x are minus 1 and minus 5. Find the equation of k of x. So listen, we work with what we have. What you have over here is your turning point, or that is your vertex. So we can find your k of x using the vertex formula. So k of x can be expressed as a over x minus p squared plus q. Now my p is minus 1, my q is minus 5. So I have a x plus 1, as minus and minus will turn to a plus, and then minus 5. The only thing that we also need to find here is my a. A is the leading coefficient. And what we know over here is that my k of x is the image of h of x. So it will be the same graph, but moved maybe into different direction. So that means that if it's the same graph, they must have the same leading coefficient. And that leading coefficient was just 2. So at the end, my k of x can be expressed as 2 x plus 1 to be squared minus 5. So that's so when it comes to a vertex form. And then moreover here we have, you can see that solve the equation like this. So first of all, I want to get rid of the fraction. So what I'm going to do here, I'm going to use the method 1, 2, 3, 4, and then I get 3 by 5 is 15, plus 2 cross multiplication is 2 by 2x plus 1 over 5 by 2x plus 1, and that is equal to 2 over 3x minus 1. I simplify this, So that will give me 17 plus 4x. After removing, I have 4x plus 2. So 2 by 15 is 17 over 10x plus 5 equals to 2 over 3x minus 1. So now fraction on both sides. Let's do the cross multiplication here. And then my first multiplication is 7 plus 4x by 3x minus 1 equals to 2 bracket 10x plus 5. Let's remove the brackets. So I start with this. So it's 12x squared. And then I get what next? So it's 51x and then minus 4x, and then finally the last term should be just minus 17 is equal to 20x plus 10. Let's move everything to one side, so I will get here 12x squared. This and this will give me 47x, and when I move the 20x to the other side, that turns to minus 20, so I get 27x, and then I have minus 27 equals to 0. I divide here everything by 3, so I get 4x squared plus 9x minus 9 equals to 0. Let's factorize this now to find these two solutions. So I will go with the 4x and x. The final is minus, so I must have a 1 plus 1 minus. Factors of 9, that gives me 9. Let's try 3 and 3. We use the rainbow rule to find out if the middle term is correct, and you can see that I get 3x and minus 12x, so that will give me minus 9. So the only thing that I need to change is minus and plus. When I get that, I can let each of my bracket equal to 0. So then 4x minus 3 is equal to 0, and then x plus 3 equals to 0. Two solutions are x equals minus 3 and then x equals to 3 over 4. Okay, now I just want to double check that there is no restriction. No, all good, well done. So that's two answers. And then here I'm doing the same thing. So I keep my left side and I write that as a single fraction on my right side. So again, using the rule 1, 2, 3, 4, the bottom will be x minus 1, x minus 5, and the top will be 2 by x minus 5, and then plus 1 over by x minus 1. Let's remove the brackets and simplify that. So it's 1 over x equals 2x minus 10, and then I have plus 1x minus 1 all over x squared, and then I get minus 6x and then plus 5. Let's simplify the top again. So 1 over x is equal to 3x minus 11 over x squared minus 6x plus 5. Now I do the cross multiplication. So x squared minus 6x plus 5 is equal to 3x squared minus 11x. I forget about the power. And now I have another quadratic, move everything to one side. I keep 0 on this side. So it's minus x squared. So I get 2x squared. Then plus 6x ends with minus 5x and then minus 5. And then what I have to do here, I try factorize it. Okay, and then you can see that now when I do that, 2x and x, factors of 5 that will give me minus 5. No matter what, how I put them, I will never get the minus 5. So if I cannot factorize, then what options do I have? Using the minus b formula. Okay, so you just sub it in for a equals 2, b equals minus 5. Make sure that you use the right sign, and then c is also minus 5. Use to the formula to get the two solutions. Okay, and now finally the last one about the quadratic function. So here you have the 3x squared plus 8x minus 35, and they want you to find the roots of f of x. So again, to solve this, I let that equal to 0. And I will try to factorize this. So open up the two brackets. How will I break the 3x squared? Well, it will be 3x and x. And then the final is minus, so one must be with the plus, the other with the minus. I would go with 7 and 5. And how will I put them to get 8x? I put 5 over here, 7 over there. Let's try what will be my middle term. That's 7x minus 15x. Yes, I get, but minus 8. So I need to still change the sign to opposite. It's minus and a plus. And then after letting each bracket equal to 0, my one solution will be 7 over 3. The other will be x equals to minus 5. And that's my roots. And now here another equation, quadratic equation. They want you to solve it. So I open up the two brackets, x and x plus and minus factors of 20 that the difference is minus 1, so that must be 5 and 4. So the two solutions are minus 4 and x equals to 5. And as you can see here, there is a second part of this question when they ask you to hence solve another quadratic equation. Okay, so hence means you use the previous work, and my previous work was finding the roots of this equation. So what you need to see here, you have to spot the difference or what was the same or what has changed. Okay, and you can see that with my new equation, 2k plus 2 over k is my x from the previous, from the old one. Okay, so if I found the solutions for my first equation, let's use it to find my k. So 2k plus 2 over k is equal to minus 4, and then 2k plus 2 over k must be equal to just 5. Okay, I have two more equations to solve to find my k. So first of all, I want to multiply everything by k to get rid of the fraction. I will get 2k squared. Now I bring this, so that will be plus 4k, and then plus 2 equals to 0. I divide everything by k, by 2, so it's k squared plus 2k plus 1 equals 0. Factorize this and you get the same bracket. So it's k plus 1 to be squared equals to 0. So my k will be equal minus 1. So here you have a double solution. For the second one, I multiply by k, so it will be 2k squared. Then move the 5, so it's minus 5k plus 2 equals 0. Factorize that. And then I have 2k and k minus and minus 2 and 1. Okay, that will give me 5. So my two solutions are k equals a half and k equals to 2. So that's it when it comes to a quadratic equation and factorization. In my next video, I will focus on cubic functions and polynomials and also simultaneous equation. So please stay for more. Thank you for watching.